Okay, so let's go over the homework. I know it's been a couple weeks since I've done any video for you guys, but I really wanted you guys to take the identities, according to however you wanted to do it. All right, homework is numbers 51 through numbers 58. Right, so let's start with 51. 51 is cotangent square x minus cotangent square x times cosine square x. Right. Now, there's couple different ways. There's a couple different ways you can do this, but I'm going to go ahead and say, you know what? Since each of these has a cotangent in here, this is a bigger term, but for that term, it has a cotangent in there as well. I'm going to go ahead and factor out a cotangent out of both those terms. Right, so if I factor a cotangent out, okay, so it's going to look like cotangent square x has been factored out. And left over, I will have a 1 because from this term, if I take a cotangent out, I will left with 1. And then with this term, if I take a cotangent square x out, I'm left with cosine square x. Okay, so that's what I did. And then from here, this is a factor already, right? If you want to go a little bit more, you want to go a little further, you can say, well, this is actually a trig identity. This 1 minus cosine square x. This is a trig identity. Okay, so this right here is the trig identity of sine square x plus cosine square x equals 1. And notice if I was to subtract cosine square x to both sides, I would have sine square x equals 1 minus cosine square x. So I can actually use this as sine square x. So if I wanted to, if I wanted to keep it as factored, I would be, more or less done, or I can even write it as cotangent square x times sine square x. And, that would be even better if I was to wanted to factor it. Okay. But then I can go even further. And I can say, well, I know trig identity for cotangent. Cotangent is actually cosine square x over sine square x. And then multiply by sine square x. You can see what happens here, right? I can cancel these out. And if I was to keep factoring it and working it down, at the end of the day, I would just have a cosine square x. Okay, so that's 51. You need to at any time pause it, rewind it, or review it, or whatever. Okay, 52 we did in class, so I'm not going to go over that. Okay, in both third and in both fifth period. So I'm going to skip to 53. 53 is cosine square x minus 4 over cosine x minus 2. Right? And you can think of it like this. This cosine square x minus 4, you can think of it as a x squared minus 4. Right? What can you do with that? Right? So x squared minus 4, you can rewrite it as x plus 2 and x minus 2. Right? So that's what we're going to do here. So that cosine square x minus 4, we can rewrite that as cosine x plus 2 and cosine x minus 2. In the bottom, guess what you have? Cosine x minus 2. Looky, looky, you can cancel that. And at the end of the day, you're down to cosine x plus 2. Okay, and you can say that's your answer. Okay, kind of like the first one, you can say that this is your answer. Okay, so when we factor it, we want to get it down to as small as we can, and we want to have individualized terms. 54. Okay, 54 is, it's the same story, cosecant square x minus 1 over cosecant x minus 1. And again, we can think of this cosecant square x minus 1 as x squared minus 1. And we know that's going to turn into x plus 1, x minus 1. So what we can do here is cosecant x plus 1, cosecant x minus 1. On the bottom, looky, you have the same thing on the bottom as there is on top. So your final answer, cosecant x plus 1. That is your finale right there. Okay? 55. We have tangent fourth x plus 2 tangent square x plus 1. Okay? Now, you can think of this as, I'll write on the side, x to the fourth plus 2x second plus 1. Right? By doing that, you can factor this. Okay, this is a little more advanced than x squared because this is x to the fourth, but you will still factor it, and it will come down to x squared times x squared, and that will be plus 1 plus 1. Okay, and if you check it out, you'll actually get all three terms. All right, so from there, I'm going to go ahead and just say, hey, you know what? This tangent fourth x plus 2 tangent square x plus 1 comes down, or factors down to tangent square x plus 1 and tangent square x plus 1. Okay, and this is fine. This is, factored down already. But if you want to go a little further and you want to use your trig identity of, I'll write it on the side. If you want to use this trig identity, your secant, the way we wrote it, I just want to make sure it kind of matches what we wrote. The way we wrote it was 1 plus tangent square x equals secant square x, right? So what we have here is already here, which means that we can replace it with that. So instead of tangent square x plus 1, we can rewrite it as secant square x times secant square x. Okay, even better yet, secant to the fourth x. Okay, and I can say this is the best answer you can have, but all of these right here in purple, all of these are good for factors. Okay, 56. Got 1 minus 2 sine square x plus sine fourth x. Okay, and we can say that this right here is similar, use blue, to 1 minus 2x squared plus x to the fourth. Okay, which is going to factor down to 1 and 1, because that's what makes 1. X to the fourth is going to be x squared and x squared, and to get a minus 2x squared, you need both of them minuses. Okay, so this one right here is going to end up being 1 minus sine square x and 1 minus sine square x. Okay. Again, this is fine. This is fine if we're just factoring, right? But if we want to keep going a little bit more, right? We can use the trig identity of sine square x plus cosine square x equals 1. You can see how this almost looks like it. If we were to subtract sine square x from both sides, and these would cancel out, we would have cosine square x equals 1 minus sine square x. Meaning instead of writing 1 minus sine square x, we can write down cosine square x. Right? So this one, finally, we can have as cosine square x, and the same thing again, cosine square x. Or better yet, cosine to the fourth power of x. All right? That's 56. If you need to pause it or review it, do it. Okay, 57. We get a sine 4 of x minus cosine 4 of x. Okay, this comes down to, well, let's see what it looks like. Right, so this is the same as x to the fourth minus, and that cosine is a different function, so we have to call it y to the fourth. Right, now with that one, you can do it like this. You can rewrite it as x squared plus y squared and minus y squared. Okay, if you check it out, it'll actually work out. Okay, so by doing that, I can rewrite it as sine square x plus cosine square x times sine square x minus cosine square x, like that. And we know from our trig identity, actually I won't write it down, this one up here, right? This trig identity up here, that sine square x plus cosine square x equals 1. So this part equals 1. This part is still going to be sine square x minus cosine square x. Okay, and we could just finish it off with sine square x minus cosine square x. Okay, I am good with this. Okay, now some of you guys may want to change it all to cosines or all to sines. So for example, you can say, well, you know what, sine square x, right, is the same as 1 minus cosine, kind of like how I did before up here, where I erased it already, right? Sorry, that was a scribble. But you can say, hey, sine square x is actually 1 minus cosine square x. And then you still have the minus cosine square x. So you can work it from that angle and say this is equal to 1 minus 2 of the cosine square x. And if you want to go this route, you're good with this as well. I'm good with that. Okay? But I'm also good with this up here. Okay? Because that's pretty good. Okay? So either way, I'm going to go ahead and erase that bottom because just wanted to show that you can keep going. You can overdo a lot of things. Okay? And a lot of times you don't want to overdo it. Okay, last one, 58. Okay, 58 is secant 4 of x minus tangent 4 of x. And same idea, right? So we're going to go ahead, and I'm not going to do the part with the x and y, but same idea. We're going to go ahead and rewrite this as secant square x plus tangent square x times secant square x minus tangent square x. Okay, so the trig identity we need, right, is that 1 plus secant square x, right? So let me write it down. Sorry guys, having a little trouble with that. But so the trig identity we're going to be using is the secant square x one. So let me see how I wrote it in class. I think I wrote it as 1 plus, right? 1 plus tangent square x equals secant square x, okay? Or something similar to that. I might have put a tangent in the front. I'm trying to remember. Plus 1 equals secant. Okay? But you can see it's the same thing, right? All I did was just switch these two. All right, so don't worry too much about the order of it if it's adding or multiplication. You only have to worry about it if it's division or subtraction. So, all right, so if you look here, um, this one looks almost like this, right? I mean, it looks like this too. Look at that. But if I was to take this tangent and move it to the back, right, I would have to subtract, right? So I would go minus tangent square x and minus tangent square x. Okay, and these would cancel. So I would get 1. Sorry, I want blue. So I would get 1 equals, that cancels. 1 equals secant square x minus tangent square x. Right? And you notice this right here, that's what we have right here. So all of that is equal to 1. So we have secant square x plus tangent square x times 1, which is really just secant square x plus tangent square x. Okay, and I'm okay with this. Again, you can go overboard and you can do a little bit more, but I'm going to go ahead and stop here. Okay, so that's your homework. Hopefully you enjoy that. I sure know that I did. See you tomorrow.